Thank you very much, Ms. Ikra, for a quick introduction of this webinar and so much along with my colleague. Let me introduce myself, guys. My name is Faraz Ali, responsible for industrial safety services associated with SGS Pakistan around more than 10 years. My experience is background is from oil and gas upstream, downstream, and petrochemical and mechanical, electrical, instrument, and civil construction services. Regarding my academics, I have done double masters, one in applied chemistry and another one is occupational health and safety. And my key expertise or area of expertise is PHA, process safety management, advanced risk assessment, emergency response, and planning. Uh, I have with me my colleague Shiraz Hussain. Shiraz, if you can introduce yourself.
Uh, Hello, everybody. Good afternoon. This is Shiraz. I have 6 years of experience in upstream and midstream engineering design practices. I have been involved in conceptual phases of the project, feed, and the detailed engineering designs of it. And similarly, I have also performed several safety studies, including FNG mapping, consequence modeling for various plants in oil and gas sectors, and as well as petrochemical complexes in Pakistan. My main area of expertise are design validation, QRA, and these blast modeling, consequence modeling, etc. So let's continue the session, Mr. Faraz, if you.
Thank you. Right. So basically, a quick summary of introduction, what we will be going to learn together and how we'll be proceeding. First of all, this session, as the name expresses, that process safety management, and then we will be moving onward. Then, why do we need process safety management within our organization or within our area of operations? And then we'll have a quick introduction of process safety management, its relation with the international standard of ISO 45001, and along with the key information of some of major process safety management system which are being deployed throughout globally. And then we will be moving onward regarding one of the key element of planning phase of process hazard analysis, which is one of key element of the process safety management system. And then we will be quickly go through the qualitative, semi-quantitative, and quantitative risk analysis. And then in the second last one, before answering your question or before heading towards your questions, we will be having a quick takeaways from this webinar, and then we'll be available for to answer your questions or queries in the chat box, right? So quickly, with the brief start off that why do we need process safety management system within our organizations? Basically, process safety management uh, is due because of where we avoid or risk or to mitigate the risk of unexpected release of toxics or hazardous substance, where we are either we are manufacturing, storing within our organization. So some of the key high level or catastrophic incidents have led the organizations to understand and to get alert for some of the process safety incident. For example, the earlier one was BP Texas refinery explosion, where it caused around 15 workers, injuring around more than 200 workers, and several damage to asset and refinery assets as well. So just a quick brief what was happened and how it went through. So basically, some of the elements of process safety management system, which include process safety, pre-startup safe review were missing, mechanical integrity was inadequately deployed, some consequence modeling was not adequately performed, where uh, unattended audience were not supposed to be there, and it was there during the startup of one of the ISOM unit. So you can see some of the key minor element results in a very catastrophic incident. Similarly, in 1988, it was Piper Alpha, which sank and exploded, killing around more than 165 people on board people. And the key root causes which were identified during the incident was the condensate fluid in the pump, not knowing a safety valve on another. The major element or the failure was of inadequate deployment of permit to work system within the Piper Alpha rig site. And the most common one, which everybody is aware, is in earlier 1984, which was Bhopal disaster, which was happened due to the release of 45 tons of methyl isocyanide, which escaped from US-based Union Carbide Corporation. And I mean, it was a real disaster in the history of process safety or the industry, chemical industry. So before jumping into process safety, let's have a quick look what process means to us and how process safety is different from conventional or occupational safety. So process means either we are handling with hazardous substance, chemical, toxic, flammable, or cryogenic liquids. Either we are involved in the storage of such substance, either we are manufacturing those substance, either we are handling or utilizing, or either we are disposing those substance within our operations. So these sort of processes are called or maybe considered as a part of process, right? But let's see, for the sake of definition, just for the industry's norm, any group of vessels which are interconnected or separate vessels which are located such that the highly toxic chemicals which are involved in or maybe with an unexpected release with the single process approach. Okay. So, what is the key difference between, or how do we distinguish between occupational health and safety or process safety? When we talk about or when we consider safety, we normally think that, I mean, this will be the safety of individuals, right? So personal safety or the individual occupational health and safety do link together. There is risk of, for example, slip, trips, and fall in every workplace. So the key element which differs personal safety from the process safety is that the personal safety has the high frequency or high likelihood or high occurrence rate, but they may be result in the lower severity risks, right? Similarly, regarding the process safety, this is the blend of engineering and management skills along with or coupled with the leadership focus on preventing or mitigating catastrophic risk, near misses, particularly in structure collapse, explosions, fire, toxic release of hazardous substance within the scope. Okay. So as I explained that most of the time process safety incidents are low in frequency, but they result in a high catastrophic result, which may result in the form of fire explosion affecting the nearby community, which may affect the people around or the group of people who are working uh, within the plant, within the boiler, within the pressurized vessel containing toxic or hazardous substance. When we say hazardous substance, what we are intent to any of the substance which is toxic, which is reactive, which is flammable. So basically process safety management or process safety management system are applicable on following key industrial sectors. So either you are belong from, since I have participants from various industrial sectors, so process safety management systems are usually applicable on manufacturing industries, specifically pertaining to chemicals, petroleum refinery, petrochemicals, transportation equipment, and other chemical industries who are involved in chemical manufacturing, storage, terminals, and depots, etc. Similarly, for fabricated metal products, other affected sectors, which includes natural gas, virtual pipelines, farm products, warehousing, and etc. These process safety or the safety management system also deploys in electrical power generation and distribution sector as well. Uh, Also in gas sanitary service and also pyrotechnics or explosive manufacture where they are involved in manufacturing, storing, or even disposal of those hazardous or toxic substance. Well, one of the US regulator OSHA regulates that those organizations who are specifically dealing with such hazardous or toxic substance around more than 10,000 pounds almost similar to 4.5 thousand kilograms. So they must be regulated via OSHA regulations of process safety management system. So that's all from the side of what is process safety, why do we need process safety management system, what is process safety management system, and either as an individual, if I am working in any of the organization, do I need process safety management? So the answer is I have already explained in my this slide pack. So let's have a quick look of key elements of process safety management. How does it look like? Similarly, like our conventional occupational health and safety management system, it begins with and the process safety management again. We will be reviewing these requirements along with the ISO 45001, how it compares and how it evaluates or how it weight against ISO 45001 key requirements. So basically, complying with PDC approach, this management system starts with process safety information. I'll later on explaining how these elements proceed, and then it proceed with process hazard analysis, where my colleague Shiraz will be explaining more in detail operating procedure, considering the part of do, hot work permit system, emergency response planning, mechanical integrity, PSSR, training competency, management of change, incident investigation, contractors, and of course in the check act, compliance audits and management review, etc. So by combining those operational risk assessment along with environmental health, safety and sustainability, basically this is comprises of three of key element. Number one, considering planning, which is the clear statement from management, which is advanced risk assessment. Another one is control of operations, control of work. And the third one part is regarding the management system, which complies with the continual improvement. So one of the key important process safety management, when it compares with the standard elements, we have along with Dupont process safety management, which is a well-known and very renowned process safety management system, and most of the organizations are in the phase of deploying, and some of them are already part of Dupont process safety management system. So covering those elements, apart from number of difference between some of the process standard process safety management system and Dupont process safety management, the key difference is of basic of the 8 elements. So the more complex is the process or the operation you have, either you are in refinery, petrochemical, or you are manufacturing, or you are have a kind of similar highly hazardous process of any oil terminal or virtual gas pipeline. So the key difference element was uh, management commitment, integrated organization structure, goal, objective, and planning, safety personnel competency, effective communication, management of change, facilities, quality assurance of and or coupled with the mechanical integrity or asset integrity, and the last one, which is management of change of personnel. So basically, as DuPont has done with the standard process safety management, they have split some of the key element, for example, management of change. With the standard process safety management, we have only one management of change process. But when we consider DuPont process safety management, we have three management of change process. So basically, DuPont has split MOC process into three: facilities, personnel, and the one uh, is the processes, right? Let's have a quick look of the Energy Institute. In European Union countries, there is a high demand or high requirement, and they are regulated by Energy Institute requirement for process safety management high level framework. Along with the same theme of PDCA, they start with process safety leadership, continue with risk identification and assessment, continue with advanced risk assessment or risk management, and the last one for continual improvement to check and the auditing and to understand the requirement of management system review or the management review. So these two are the key high level process safety elements. Let's have a quick look and assess them against the ISO 45001 requirement. So again, following the theme of PDCA, process safety management system demands strong leadership. We have seen in OSHA, we have seen in Dupont PSM, we have seen in Energy Institute. So the good leadership is essential before deploying any of the process safety management, whatever is applicable or whatever the requirement, regulatory requirement is you have. That part is again covered with 45,001 leadership and worker participation. And as we have seen that the worker participation is involved in OSHA standard as well, and explicitly explain hazard analysis, which is a part of planning phase, and we'll be reviewing in detail that how this planning, or PHA we call it normally, process hazard analysis, how it differs with the different risk assessment techniques categorized under qualitative risk assessment, semi-quantitative and quantitative. I mean, where do I need qualitative risk assessment? My existing risk assessment are sufficient for my particular process, or do I need to further advancement in semi-quantitative or the quantitative risk assessment? So basically, again, the process is similar: hazard analysis, quantification of risk, risk mitigation, and then looking for the opportunity. Management of change, we have seen in the Piper Alpha case, like the inadequate permit to work system, inadequate management of change system. So this is again the part of operational control as compared with ISO 45001 requirement. Design intent is also the part of implementation and operational control if we compare with ISO 45001. So on the extreme left side is process safety management system elements. The right extreme right is ISO 45001 key requirements to establish if some of the organization wants a continual improvement system of process safety management. So competence management, once again, it starts with the training need analysis coupled with training plans, competency assessment, and then continual improvement of each of the process plant operator or the person involved with in operational maintenance and research and development. Control of contractors, we all are aware that most of the part in process industry is done by a contractor. Nonetheless, if I'm not wrong, maybe in some organization, more than 60% of the operations or the jobs are being done even during shutdown by the contractor. So control of contractor is one of the key element, and this is also covered under operations section of procurement of ISO 45001. Asset integrity planning, risk assessment and control. Again, the safety critical devices which are responsible for the safety of personal, plant, and the nearby community. So, I mean, if their failure can result in the form of leakage or spillage of those toxic chemicals which are being used or deployed or produced within our operation. I mean, those devices whose failure could result loss of containment of hazardous substance. For example, relief devices, emergency shutdown system, alarm systems, or sensors, etc. Incident investigation recording, one of the reactive indicator for process safety management, which highlights the organization where it is trending to. I mean, if if the trend is increasing incidents, so that results that the less effective process safety management is deployed, or maybe inadequate safety management system is deployed. And the last one, which is performance monitoring and measurement and auditing. I mean, just to evaluate that what are the goals and objectives were set initially in the planning phase, and right now at the end of the year, how the organization is being is monitoring their performance indicator, which are maybe leading or lagging indicators to monitor their process safety management system performance. As I said that during the planning phase, it requires a continual improvement of the whole management system. This is the key requirement, one of the ISO 45000 system or any of the management system, that they needs a continual improvement within the system. So this is all regarding the process safety management system and ISO 45001. Basically, here we have 18 different frameworks of process safety management. When we talk about frameworks, so basically they are simple elements which are reorganized. Some are coupled, some are split based on the toxicity or based on the complexity of the process. For example, if we talk about any of the terminal whose key operations are to perform filling of the tanks and then decanting with the help of lorries, and the toxic or the flammable fluid is transport via tank lorry. So the operation is quite simple. There is no chemical reaction is involved. Simply filling and decanting of tank, and then again transportation of these toxic may require simple process safety management compared to any of the organization who is responsible in chemical manufacturing, for example, polyvinyl chloride PVC, or maybe polyethylene terephthalate PET. So, and similarly other complex refinery operation where we have certain isom unit, for example hydrocrackers and other uh, lighter hydrocarbons refinery. So one of the highlighted ones with the orange color are the key well-known process safety management system. For example, 14 elements of OSHA, 20 elements of Energy Institute, similarly 12 elements of Chevron, and the earlier 14 elements were also adopted by Dupont, usually named as process safety and risk management. Later on, Dupont had further conducted advancement in its element, and now they have become 22 elements. So let's talk about the PHA, the second element of process hazard analysis, which is a part of key activity, part of planning phase of any of the process safety management system. So what PHA is? It is a thorough, orderly, systematic approach to identify what are the hazards associated with the plant and how these hazards are evaluated with the frequency of or the likelihood, and after the conversion of into the risk, then evaluating risk and then deploying the key measurement to mitigate those risks. Similarly, like other risk assessment, our PHA must be updated, revalidated a couple of years, maybe by the 3 years or after the 4 years, or if any of the incidents occur, or any technological change occurs within the part. Some of the key techniques or which are being deployed as a part of PHA. Number one, and the simplest one, is what if analysis, hazard identification or risk register development during the design phase, HAZOP study during the design, during operational, or during any key level management of change occurs. Failure mode and defect analysis of packages unit, similarly fault tree analysis or any other appropriate equivalent methodology, for example, event tree analysis. So basically, PHA team is how it comprises, how it is being done by the team. So PHA team is normally comprising of engineer, process engineers, design engineer, operation, maintenance staff, and along with independent person who does not have any sort of business or financial stake with the organization. So this gives any organization edge to truly identify the hazard, truly evaluate the risk, and to provide guidance how truly the risk can be mitigated and the operation or the process can be safe. So risk assessment approach. The risk assessment is normally split into, you guys have might understand that in our offices, normally the risk assessment which is being deployed is called qualitative risk assessment. Why? Because in our offices, operations are a bit simple and they do not have any sort of any complex reaction or any sort of higher hydrocarbons or toxic chemicals within our operation. So the risk methodology usually involves with the good decision maker. For example, for the qualitative, we normally identify the frequency of hazard which have been identified. We evaluate against certain severity, and then we categorize into low, medium, high, and then we start deploying our control, and then we reevaluate that what is our existing risk right now and what are our future plans or roadmap to further mitigate risk. Similarly, for semi-quantitative, we go further to extend that what are the higher risk and how we can, and how up to what extent they can harm our people or the group of people who are involved in such processes. And quantification or quantitative risk assessment, the answer is when we have a certain complex processes, the level of estimated risk again coupled with its proximity of the limit of tolerability. Similarly, the higher the complex process is and the higher the quantification we are heading to conduct those sort of risk assessment. Like in our offices where we are ultimately surrounded by lower potential risk, we normally conduct a qualitative risk assessment. But when we talk about refineries, petrochemical plants where they are involved in manufacturing or production of hydrocarbons, toxic chemical, hazardous substance, so we usually deploy the higher risk or the extreme quantitative risk assessment. So before I hand over the floor to my colleague Shiraz, uh, Shiraz will be explaining more in detail of some of the key techniques of PHA, which are normally deployed to mitigate those risks within the area of operations. Thank you, Shiraz.
Thank you so much, Mr. Faraz. As you guys are aware of the potential of the workplace hazards and their consequences of causing injuries, deaths, and financial losses. So a safety plan shall be developed and deployed by understanding the hazards and their consequences to the plant. For that purpose, we have several techniques, as my fellow has explained. Let's just start with HAZID. A HAZID is a common structured technique which identifies hazards at an early stage of the project. Hazards may relate to process or non-process sides, including the manual handling of chemicals, the transportation stuff, and as well as the process hazards, including the release of toxic chemicals, flammable gases, the explosions, etc. So it's the main benefit of hazard is that it identifies and gives a clear picture to the management to the decision to be taken for that risk mitigation, and that ensures that our project overall will ensure the employees' safety. Uh, Moving on to the next slide for the HAZOP. So uh, in place when we have done hazard and we have identified different risks, and then that risks are basically considered in HAZOP. HAZOP is particularly focused on identifying and evaluating the hazards related to the process and operability of a plant, and it helps it's also a structured approach. The goal is to identify and deploy appropriate safeguards, or to firstly to evaluate what are the available safeguards, and to deploy certain measures that are feasible, and as well as they will reduce the risk to an acceptable level. It's basically performed by using guide words, which enables a multidisciplinary team ranging from the process side, the mechanical side, the operational side, and they are focused and they are guided by some guide words which are perform which take account into the parameters and the deviation from the normal operation, and that this whole thing basically enables the team to move in a focused direction and question rigorously for the hazards that may happen, and question and to assess the plant's safety and evaluate its safeguards. It's basically performed against IEC 61882, and it can also be performed for the startup and shutdown scenarios, and well as the state operations which we are running through. So that's we can understand what HAZOP is. And moving on to the next one is that moving on to the next slide of SIL. The SIL assessment basically results in the risk or high severity risk identified in the HAZOP study that needs to be catered, and the SIL study is performed after the HAZOP. First, we perform HAZID, then HAZOP, and then we perform the SIL study. The SIL study consists of a same multidisciplinary team, but they are more focused and more detailed inputs on certain hazards. We basically perform that the SIL study using the LOPA analysis, layer of protection analysis, And in 9 steps, basically, we assess what is the process, and if that process isn't inherently protected, which we all know that no process is inherently protected, we gradually deploy certain measures ranging from basic process control system, and if that's also not enough, we then deploy alarm and operating intervention, and if that's not enough, then we go forward to safety instrumented system, which basically cuts off the hazard. And then if that's not also reducing the risk to an acceptable alarm level, that is as low as reasonably practical level, then we move on to physical protection, relief devices, and then to physical containment, burns or vessels or scrubbers, etc. And then if that's not also reducing the severity of our complex process, we then move to deploying a fire and gas system, and then to further to plant emergency response, and then to community emergency response. But these levels are assessed, and it's a goal to avoid that we do not fall into the last regions, and we mitigate our risk in the initial stages of cell study. It's basically performed against IEC 6155113. Provide guidelines on the determining the cell for the safety instrumented function of each application. Uh, it's basically experience performed against experienced people and their relevant experiences against the incidents. So moving on to the next slide. Okay, QRA, as my fellow colleague has explained, that QRA is standing for quantitative risk analysis. In qualitative risk analysis, we evaluate what are the risks and identify their frequencies. However, in qualitative risk analysis, it basically gives an idea of what the extent of damage would be, like in numbers, which qualitative risk assessment doesn't do. So for a layman or for normal operation in normal engineers, it's qualitative risk analysis is enough. But for management to deploy a safety system, they need to know the extent to which the consequence of an hazard could result in. So for that purpose, a QRA analysis is performed, which basically involves consequence modeling. It basically estimate fatalities, which can be individual, group, or societal. It also predict economic losses, which are certainly related to the loss of product, loss of human lives, and loss of the damage to the environment. It basically helps in deploying a safety system, which may result in the reduction of that hazard. So for that whole purpose, a QRA is a detailed study performed as a desktop job as well, and that is essential to basically visualize the extent of the damage. So for consequent QRA, we have I am sure we have you guys have idea about the QRA. Let's move on to the next consequence modeling. A consequence modeling is basically sub-step of a QRA, in which we basically form the amount of hazardous material release is determined. We perform consequence modeling to determine what hazard can occur in our plant. In a normal operating plant, what hazard can be occur from any flange, any leak from any flange, any vessel, a rupture from a tank, and a fire resulting in a pool of leakage crude. So for that purpose, the amount of the fire radiation, the amount of the gas plume, the amount of the toxic chemicals intensity is determined by consequence modeling. It's performed on specialized softwares, and the dispersion of the released chemical, its extent, its height is evaluated against consequence modeling. And similarly, we also can assess the overpressure on humans equipments by blast modeling, which is also in the step of the consequence modeling, and the distance and travel area required for a safe operation, which this whole consequence modeling helps us to identify or deploy certain measures that may result in the evaluation of the risk to a building or for control room of a plant. Let's say we are in the stage of building a plot plan for a plant. We need to perform consequence modeling, which may evaluate us with a number that is the severity of the risk, and which will be the resulting factor or the deciding factor for the design of a control room and to the severity of it. So for continuous modeling, there are two things which can be done. We can also perform continuous modeling on 2D scale. That is, it will result in performing our continuous modeling on a 2D plot plan or giving it a side view. However, we can also perform continuous modeling on 3D plot plans or 3D software, which will result in the 3D imaging of that consequences. That the main purpose of the 3D imaging is that it helps in visualizing the intensity or the extent of the damage. For example, the video that is displaying in front of you guys, in front of you all, it's you can, as you can see, the release of a gas LEL of the gas plume can be easily visualized by a 3D plot plan, by a 3D consequence model, and you guys can easily relate to the extent of the damage. However, 2D plan doesn't it helps in easy visualizing of the damage. So here comes the role of the 3D plan, where we can basically understand the real extent of the damage. So moving on to the next FNG mapping. FNG mapping helps in FNG mapping. What is FNG mapping? Let's say we have a plant and there is a potential for a gas leakage or a fire hazard. We need to evaluate it at the source and to cut off or take measures so that the risk is mitigated at its source and not after its propagation. For that, we deploy or install fire and gas detectors. But to evaluate the optimum number of fire and gas detectors, we have to perform its mapping first. And that 3D mapping helps us in the overlapping of the detectors coverage and helps in determining the optimum number of detectors, which is performed in the 3D live 3D model of that certain plant. So that's where rules of FNG mapping helps in. And then moving on to the fire and explosion risk assessment, as its name implies, it's basically quantifying the fire and explosion accidental events and their consequences. Its main objective, again, it's related to the consequence modeling and QRA. Its main objective, it is to determine the extent of the damage and to take certain measures which may result in the safe operation of the plant, the workers, and the environment. So we can design the layout of the plant as well accordingly if we are aware of the hazards that may result from the fire and explosion. So that's the prime purpose of this fire and explosion, which is also called FERA. So moving on to the next slide, I think yeah, that's enough. Mr. Faraz, will you take over this from the Okay. Okay. So no problem. So what's in it for me? As we all have you all have discussed about these stuff as you have attended. So I'm sure you guys are aware of the process safety framework, how it works, its deployment solutions, what is a hazard, HAZOP, QRA, FERA, dispersion radiation modeling, and what is safety auditing, PSM auditing, its training. I'll take this opportunity to introduce you guys the services of SGS Pakistan. We are involved in the process safety deployment of the process safety framework. It's auditing, the performance of HAZID, HAZOP, QRA, FERA, dispersion radiation modeling, consequence modeling, the auditing of existing systems, process safety frameworks, and as well as deployment of the trainings of for these systems.
Thank you, Shiraz. Thank you so much for identifying the industry's well-known best practices and process hazard analysis technique, which is covering from consequence modeling, qualitative risk assessment, semi-quantitative, and QRAs. So basically, what are the key takeaways which we have summarized the whole presentation? One part was already process safety framework, comprising of various different standards of OSHA, Dupont, and energy institutes. And so with the deployment of right level of process safety framework can help you guys or the organization to reduce the catastrophic risk of your operations. Either you are involved in storage, manufacturing, or transporting those hazardous substance. When we say hazardous, it covers, of course, the toxicity, the flammability, and the asphyxiation as well. So yes, with the help of deploying correct or deploying the right tool during the planning phase will help you to establish or to monitor your performance indicators, or which you can assess the right level of process safety management with the help of auditing techniques to understand where your process safety management framework is heading to. Either it's your system is continually improving, or you need further actions to improve your process safety management. This can, of course, when we say auditing, it has to be coupled with people competency. And we talk about when we say competency, it is coupled with training need analysis of various stakeholders of within the organization, starting with the operation, maintenance, research and development team, and instrument team as well. So with this, thank you so much, guys, and over to you, Miss